Now the next thing we're going to discuss is the DI box, which is a machine like this one. A DI box is an important device because it allows us to essentially take an unbalanced input and make it balanced. Okay, so we would be going from this type of input, which is unbalanced, like an acoustic guitar or a keyboard, and we will be going into this type of output or cable that will connect us to a balanced device, like a preamp of a mic. So we go inside unbalanced, we go outside balanced. However, there are other issues that this little unit facilitates, and let's quickly look at them. There is 3 different things that this thing does, and I want you to understand all 3 of them. There's few more possibly, but I just want to speak about 3. Okay, the first issue is if we have an unbalanced input or unbalanced signal, we need to balance it. So we need a DI box to do that. Then there's other two more. Every single preamp, or there is a generic rule of thumb, which is every time you connect an electronic device, you go from low impedance to high impedance. Generally, the relationship is between 5 times bigger to 10 times bigger. In other words, if I got out of a mic, which is about 100 to 200 ohms, impedance is a definition of resistance, electronic resistance, measured in ohms. If I go out of 100 ohms, I must go into about 500 to 1,000 ohms. Okay, that's kind of the rule that help connecting devices. Out of low impedance into high impedance. Okay, you got it? Now, let's quickly take a guitar or a keyboard. The output of a guitar and the output of a keyboard, it's high impedance. A keyboard will be in the 1,000 watts to even 10,000 ohms. Okay, there's not even to talk about something like a Fender Rhodes, which I played you a few weeks ago. That's got very different electronics, but that's in the millions of ohms, because it runs a magnet like a guitar pickup for every string. So it's got a lot of strings in this. It's like an electric piano made like a guitar. It's fascinating. But I'm not talking about that. Let's just take a normal keyboard or a normal acoustic guitar. They got high impedance. But the mic, the preamp that you're using at the mixer, if you're using an XLR input, would have a low impedance compared to that. A lower impedance. Or the same. And you need to go from low to high. Okay, so let's just do the math. If I go out of a keyboard that is about 1,000 ohms, I need to go into about 5,000 to 10,000 ohms input. Okay, but the preamp of a mixer, if you go into the XLR, is about 1,000. So the balance is not there. I must go from 1,000 to 10,000. I'm actually entering 1,000 ohm impedance, more or less, which means I must reduce the impedance of the keyboard. Are you getting this? I cannot go from a high impedance to same impedance. I must make the impedance of the keyboard lower so that I can get into the mixer in the right impedance. Okay? Now, the DI does that. So I go from high impedance input to low impedance output. As you can see, it is written here, 600 ohms, which is lower than whatever you put in. It says here, low impedance out, 600 ohms max. Okay? For the record, something quite fascinating is that impedance actually has even a role in tone. And impedance matching is actually quite important. We're not going to talk too much about it, but all I want to say, it is not just the electronic aspect of it which is incorrect, but even from a tone point of view, if you don't do this correctly, it has an effect on it. The third thing that this machine does is that it attenuates the signal. It attenuates the voltage. Again, let's go back to we're patching the keyboard into a mic preamp. The mic preamp has a limit of how much voltage it can handle. Let's just use a figure for the example. Let's say the preamp can handle maximum 1 volt. Okay. But when you come out of the keyboard output is 2 volts. Now obviously that preamp, even though you put it at the minimum, it would be overloaded by the voltage output of the keyboard. Okay? So you got a gain at the minimum, the keyboard is playing, and is distorting. Have you ever come across something like that? If you've done live sound without DIs, you would have come across something like that. That's why this DI, like every DI, has a pad. And the specific design of this one is a 15 decibel pad. So it reduces the level 2.5 times, depending on which unit they use, but possibly 2.5 times to 5 times smaller. So it cuts a lot of voltage. Okay? So if you had a keyboard too high for the mic preamp on the mixer, push this in, and suddenly the voltage is reduced, then there's no distortion. You can bring the gain up. Okay, so let's go back to the keyboard example and make a comparison with and without the DI. Keyboard to mixer connection using that cable that I just showed you earlier. Jack on one side, XLR on the other side. We short cold and ground. I have 3 problems. Line is unbalanced all the way. The impedance is wrong because I go from high impedance instead of going from low impedance. And thirdly, this keyboard of mine has got a voltage output that is too great for the input of the mixer. So I've got 3 issues. All 3 issues are solved with this, believe it or not. So do you need the DI boxes? Absolutely. They're absolutely fundamental. They're not a nice to have. They're not a, well, if I have the budget, I can have them. You have to have them. You have to have them every time you go from a stage into a mixer, out of balance into unbalanced to balance, high impedance and low high voltage. You need this. You might say, are there exceptions? Yeah, there can be exceptions. Let's say you have a CD player which has got a unbalanced output, even though CD player, or let's use a more common example now, maybe a computer, which got a mini jack output. The mini jack, essentially, it's an unbalanced output with a ground and 2 lines, left and right. Now, you have a very short cable, maybe a meter from the computer to the desk. You split that cable into 2, a left and a right. The left has got a ground and a signal, and the right has got a ground and a signal. And then you go into 2 channels of the mixer, or a stereo channel, which has got 2 connectors. Okay? So, because of the length of the cable, you don't need one of these. Ideally, yes. You should balance everything, but in practice, if the length is not very long, it's not too much of an issue. Okay, but you had the same computer on stage, like somebody is doing a presentation on stage with a laptop, and you want to have the signal coming into the house. It would be recommended to balance it for all the reasons I've given you. There's also another thing that most DI have, which is they lift the ground, especially with the laptop, which generally have a transformer that powers the computer to have different voltage. It's always very, very advisable to have something that can lift the ground. So if there is a hum, it's generally because of a voltage or a current difference between an input to 2 different electronic devices. Then you can just lift the ground. And generally, depending on what is causing the hum, this will get rid of it if the reason is electronic in this sense of a difference of potential between 2 sources. Then you can just lift the ground and the buzz should be gone or the hum should be gone. Okay? So this is, okay, you're getting this thing of the comparison. Computer next to the mixer and computer on stage. 2 different scenarios. The one, the unbalancing will work. In the other scenario, it might not work and it would be unwise not to have one of these. Okay. What type of DIs do you get? You get 2 different types of DIs. This is a passive one, meaning that doesn't require any electricity or any voltage to function. So you connect this here and I connect that out. If I put a guitar here and I measure the output here, it will give me voltage. It doesn't need anything to function. Then you get active DIs, which will require some kind of voltage or current to function, and you can provide it either with a battery or with phantom power. So that's generally kind of the main two difference, active and passive. Then you get DIs which are designed to run two lines, or stereo DIs, where you will have two inputs and two outputs. Right now, these two jacks do not represent the stereo input. What are these? This is the input and this is the through, meaning that it loops the input so that you can connect the same input like a bass guitar to an amp or to something else. So let's use the example of bass guitar. You go out of the bass guitar into the input. From the XLR output, you go to the stage, to the mixer, and from the through output, you go back to the amp. So you essentially, it's like the guy is back to the amp. He used to, without the DI, would go from the bass guitar to the amp. Now he has put the DI in between. That's literally what it means. So this is the through, it's not a second input. Okay. The other thing that some makes are doing these days, which is quite beneficial from a tone perspective, they are changing, like the Radial is one of the few that is doing this. They're actually changing the impedance relationship between the input and the output according to the type of instrument that they are DIing. And that's got some interesting advantage on the tone. But anyway, just I mentioned that just for the record, because there is something about impedance that affects tone, and it's quite interesting to listen. There's even a very advanced processing unit in studio setup where you can vary the impedance. There's different steps of impedance according to what instrument you want to connect to this device, and it's quite beneficial.